couple different things we were talking about in today's notes. We were talking about what is called literal equations, as well as formulas. Literal equations and formulas. We're going to start off with a little bit of vocabulary. We will define each of these terms, starting with literal equations. A literal equation is an equation, so it has an equal sign, involving two or more variables. If we have two or more variables, then it is a literal equation. So we've been solving lots of equations. 3x plus 2 equals 11. We can solve that equation. We've been doing that. If it has two or more variables, 3x plus 2y equals 11, I have two variables, x and y. That is now a literal equation. Again, literal equation, an equation involving two or more variables. And then the other term we need to look at is formula. A formula is an equation that states a relationship among quantities. An equation that states a relationship among quantities. A formula you may be familiar with is area of a rectangle. Area of a rectangle is length times width. That is the formula relating the area of a rectangle to its length and its width. So we will be solving these literal equations as well as working with formulas today. Example 1. Example 1 asks us to solve this equation for x. We are given ax plus b equals c, and we are asked to solve for x. Notice this looks way scarier than the typical problems we've been working with. The equations we've been solving look a lot more like this. 3x plus 2 equals 11. That's the one we wrote up there before. But if you look at this, we're solving for x. I've got my x. It's in the same spot. And I've got something in front, something right here, and something on the other side of the equal sign. These two equations are very similar, and the steps to solve them are going to be exactly the same. It's just we're working with multiple variables here, whereas here I just have numbers in one variable. But the steps are the same. So if you can think through the steps to solve this, that's the same as the steps to solve this literal equation. So we've done so many problems similar to this one. The first thing I should be doing is subtracting 2 from both sides. These cancel. I get my 3x equals 11 minus 2 is 9. Well, so we subtracted this thing right here. So let's do the same thing here. We need to subtract this. We're going to subtract b from both sides of my equation. These cancel. I get ax. Here, 11 minus 2, I can combine those. C minus b, those aren't like terms. I cannot combine those variables. I just leave it as c minus b. Going back to the old problem, this is multiplication. I divide both sides by 3. We get x equals 3. Same thing works here. This is multiplication. So I divide. I'm not dividing by 3, but I'm dividing by whatever that a is. And these cancel. And I get x equals c minus b divided by a. So the steps are exactly the same. It's just I can't combine my variables like I can combine my numbers. Let's try another one. Let's call this number 2. We were asked to solve for x, and we are given x minus 6 divided by w equals z. x minus 6 divided by w equals z. If it helps to replace all of the variables, except the one we're solving for, with a number, by all means do so. So x minus 6 divided by w. I'm solving for x, so I need to leave the x in there. X minus 6 divided by, if I want to replace that with a 2 equals, and replace z with a 10, you can pick any number, it's fine. But if it helps to think through the steps on what to do here, you can do that off to the side. Notice x, we're first subtracting 6, then dividing by 2. So the first thing you would undo is the division. Multiply both sides by 2. I get x minus 6 equals 10 times 2. Let's do the same thing over here. Multiply both sides by w. W divided by w cancels exactly the same way 2 divided by 2 canceled there. I get x minus 6 equals z times w. Times, you don't really have to write the times in between. I'm just going to write zw. It's not wrong if you do put the times in there. And then we add 6, right? Plus 6 gives me x equals 26. I want to do the same thing here. Add 6 to both sides of my equal sign. Probably should have drawn my line down here. That helps. And I get x equals z times w plus 6. X equals zw plus 6. Number 3. Let's solve for a. Solve for a, and we're given a divided by b minus c equals d. A divided by b minus c equals d. And we were asked to solve for a. Well, a is right here. Think through what's happening to a. If it helps to replace all the other variables, you certainly can do that off to the side. A, we are first dividing by b and then minus c. So the last thing that happened was minus c. That's the first thing I need to undo. I undo subtraction with addition. Now it says a divided by b equals d plus c. Again, you want to think through what's happening to a. We are dividing it by b. We cancel out division with multiplication. I want to multiply this side by b. I need to multiply this whole side by b. If I write it like this, I'm only multiplying the c times b. Remember, we do multiplication first. So if I multiply this whole side by b, we need to put it in parentheses. Those cancel. And I get a equals the quantity d plus c times b. You can put it here. Usually we put times out in front of the parenthesis, like that. And we're going to leave our answer like that. If you want to get ambitious and distribute, you could. This one asks us to solve for the indicated variable. Solve each equation for the variable that's given. Number 1, we are given y equals 5x plus 7, and it tells us to solve for x. Y equals 5x plus 7, and we are solving for x. So again, you want to think through what's happening to x. I am first time multiplying it by 5 and then adding 7. So first thing we need to undo is the plus 7. Subtract 7. I've got 5x equals y minus 7. Can't combine them, leave it as y minus 7. This is multiplication. We undo multiplication with division. 5 divided by 5 cancels, and I get x equals y minus 7 divided by 5. Number 2, y minus 4 equals 3x minus 8. Y minus 4 equals 3x minus 8. We were asked to solve for y. Solve for y. Y minus 4 equals 3x minus 8. Here's my equal sign. Think through what's happening to the variable we're trying to solve for, which in this case is not the x. We're trying to solve for y. We are subtracting 4. That's the only thing we do to y. We cancel subtraction with addition. Y equals 3x, negative 8 plus 4. I can combine those. Negative 8 plus 4 is negative 4. And I've already got y by itself. Y equals 3x minus 4. That's it. Number 3. Number 3 asks us to solve for y, and we are given 2y plus 4x equals 8. 2y plus 4x equals 8. I'm solving for y. I'm multiplying y times 2, and then I'm adding 4x. So the first thing we need to do is subtract 4x from both sides. Those cancel. I get 2y equals 8 minus 4x. I cannot combine those. One has an x, one doesn't. That is not 4x. And then I divide both sides by 2. Y equals 8 minus 4x, all divided by 2. Last one. We again are asked to solve for y. We are given 5x minus 10y equals 40. 5x minus 10y equals 40. Y is what we are solving for. We are multiplying it times negative 10, and then we are adding 5x. We're adding 5x because the 5x is positive. I realize this is a minus sign, but that negative sign is attached to the 10. So when I move this 5x over to this side, I need to subtract it because it's positive. My 5x's cancel. I bring down my 10y. Don't forget to bring down that negative sign. That's a common mistake I see. This side says 40 minus 5y, or 40 minus 5x. And then divide both sides by negative 10. So we get y equals 40 minus 5x divided by negative 10. And that's our answer. We're going to leave it like that. We'll work on simplifying that some other time. Y equals 40 minus 5x divided by negative 10. We're going to stop right there. We're not going to cover formulas today. We will save that for the notes next time.